Hi, in this video we'll talk about ultrasonic testing method. By the end of the video you'll be able to define what is ultrasonic testing method, know about its uses, working principle and also its pros and cons. So let us start with the definition of ultrasonic testing method. So this is a non-destructive testing method that employs sound waves to find out any sort of cracks or defects within the body of the material. This is a volumetric method, which means that the crack throughout the not only in the surface but also throughout the length and breadth of the body can be easily detected. The frequencies usually vary between 0.15 to 50 megahertz. Some common examples would be bats and dolphins. Now, you might have wondered how bats are able to detect close by objects despite being blind. So what bats basically do is they transmit ultrasonic waves, and those waves touch the object, and they come back to the bat, and the bat is able to easily measure the distance between itself and the nearby object. Now let's talk about the uses of this testing method. Now, ultrasonic testing method being a very versatile method, it finds its use in a variety of different sectors, whether we talk about manufacturing or automobile, aerospace, and even in healthcare systems. Now, you might have often seen doctors use ultrasonic testing methods to find any sort of implications or defects or faults in a pregnant woman's body. Even ships use this technique to find out items below the ocean surface. And one of the most common example of use of ultrasonic testing method is finding the thickness of the pipes in an oil and gas sector. So once we find out the thickness of the pipeline, we can easily find out the corrosion level in the pipes. So now that we're done with the uses, let's talk about the working principle. Right. Before diving into the working principle, let us first understand some of the terminologies associated with this. The first one is oscillations. Oscillations is nothing but it is the to and fro motion of the body. For example, you have a spring which is loaded by a ball, right? So imagine that you pull the ball and you release it. Now the ball starts moving up and down. So the number of times, so the motion of the ball, the to and fro motion is basically what you mean by oscillation. The second word would be frequency. Frequency is the number of times that the ball moves up and down. For example, the ball moves 5 times, like 1, 2, 3, 4, and 5. So the frequency is 5. Now, if you want to get more insight about frequency, now you can look at this diagram. This is a graphical representation of frequency. In the first case, as you can see, that there is only one cycle. So one cycle per 1 second gives 1 hertz. So that is the frequency of the first system. In case of the second one, you can see that there are 3 different cycles: 1, 2, and 3. So the frequency is 3 hertz. Similarly, for the third case, there are 10 different cycles. So the frequency is 10 hertz. And mind you, all of these oscillations, all of this cycle is taking place in only 1 second, right? Another most important formula that you need to understand is this one. Wavelength. This wavelength lambda equals v by f. V is the velocity of sound, which is dependent on the material that you select, and f is the frequency. And from this formula, what you can infer is that frequency is inversely proportional to the wavelength. So the more the frequency, less will be the wavelength, and vice versa. And it's also interesting to know that sensitivity is also dependent on wavelength. Higher the wavelength, lesser is the sensitivity, and lower the wavelength, the higher the sensitivity. So so let me just give you a small example. If I were to give you three different options, three different options. One is one megahertz. The second one is 5 megahertz, and the third one is 10 megahertz. Which one should you choose? Exactly, 10 megahertz. Why? Because 10 is the largest value, and since 10 is the largest value of the frequency, that will give a corresponding lowest wavelength value. And since the wavelength is lowest, that will give the highest sensitivity, which is exactly what we want to find out the defects. So this is basically the how ultrasonic testing functions. This is the working principle. Now let's talk about the advantages and disadvantages. The first advantage of this particular testing method is that it has high penetration power. Defects which are located even in the corners or any part of the material can easily be detected. The second advantage is that it has high sensitivity. The sensitivity is one of the most crucial factors, and this particular testing method has very high sensitivity. The third important advantage is its portability. Since very less equipments are being used in this particular testing method, it is very easy to transport ultrasonic testing method from one place to another. Now let's talk about the limitations. The first limitation is that sometimes you can get faulty errors and faulty values using this method. That is the first limitation. The second limitation is that you need you need to be a very skilled person to perform this experiment. Like, you need to have a significant amount of knowledge before trying this ultrasonic testing method. So these are some of the advantages and disadvantages of the ultrasonic testing